Assalamu alaikum, dear students. In this lecture, we will be talking about bar diagrams, the different types of bar diagrams, and how to present the statistical data with the help of bar diagrams, or we can say bar graphs. Let's first discuss what is a bar diagram. Dear students, bar usually means a rectangle or some rectangular form. Thus, a bar graph or bar diagram is a graphical representation of the data in the form of rectangular bars of equal width. Or we can say bar diagrams are those diagrams in which statistical data are presented in the form of bars or rectangles. Students, the important pointers to keep in mind while constructing bar diagrams are: all bars are based on some common baseline. That is, they should be rest on a same line called the base. Bars are equidistant from each other. That is, the space between the bars should be equal. Each rectangle or bar represents only one numerical value of the data. We should also keep in mind that the height or length of the bars differs according to different values of the variables, which means that each bar's height is proportional to the numerical values of the data. Thus, depending on the different values of variables, height of bars may be more or less, but width of the bars always remains the same. Students, the higher the value of data, the greater the length of bars and vice versa. Bars may be either vertical or horizontal. However, usually these are used in their vertical forms, where x-axis represents the categories and y-axis represents the values for those categories. Now, the types of bar diagrams. Dear students, there are 5 important types of bar diagrams. First, simple bar diagrams. Second, multiple bar diagrams. Third, differential bar diagrams. Fourth, percentage bar diagrams. And fifth, deviation bar diagrams. Let's first discuss the simple bar diagrams. Dear students, simple bar diagrams are those diagrams which are based on a single set of numerical data. That is, a simple bar diagram is used to represent only one variable or only one characteristic of the data. The different values are represented by different bars. It means that one bar represents only one figure, and as such there will be as many bars as the number of figures. For example, the figures of sales, production, population, etc. for various years may be shown by means of a simple bar diagram. Let us take an illustration here. The table given in the current slide gives data on birth rate in India according to census survey of different years. That is, it gives data on birth rate in India from 1951 to 60 to 2001 to 2010. The table, for example, shows that during 1951 to 60, birth rate in India was 45 births per thousand people, then reduced to 35 births per thousand people during 1961 to 70, and so on. Now we have to present this data with the help of a simple bar diagram. As there is only one characteristic or variable under study, that is birth rate in case of our example, we can represent it with the help of a simple bar diagram. And here in this slide, I have presented the data given in the table by means of a simple bar diagram. How to do it? Let me explain you. Firstly, draw two perpendicular lines intersecting each other at point O or at point 0. The vertical line is the y-axis and the horizontal line is the x-axis. After that, mention the years on the x-axis and use the y-axis to represent the values of the variable. And in our case, it is birth rate. So, we present the values of birth rate on the y-axis. After doing this, choose a suitable scale to determine the height of each bar, and we know that the height of each bar is determined by their respective values. Then lastly, on the horizontal line, which is called the baseline, draw the bars at equal distance with corresponding heights. So here we can easily see that the birth rate in India was highest during 1951 to 60 and it was lowest during 2001 to 2010, as can be shown by the height of respective bars. Dear students, the main limitation of simple bar diagrams is that they can present only one classification or only one category of data. If we want to show two or more than two categories of data simultaneously, we cannot do that with the help of simple bar diagrams. And for that very purpose, we have to use another type of bar diagrams, that is multiple bar diagrams. Dear students, multiple bar diagrams are those diagrams which show two or more sets of data simultaneously. That is, in a multiple bar diagram, two or more sets of interrelated data are represented. Generally, these diagrams are used to make comparisons between two sets of data, such as if we have to make comparisons between birth rate and death rate over the different years in India, we will use multiple bar diagrams. In case of multiple bar diagrams, separate bars are drawn to present separate sets of values. Table 2 given here shows the different values of birth rates and death rates in India from 1951 to 2010. The data given in this table can be very suitably represented by a multiple bar diagram as shown in figure 2 given in this slide. This figure here shows these two sets of data, that is the data relating to birth rate and death rate simultaneously. Dear students, the technique of drawing a multiple bar diagram is the same as that of a simple bar diagram. The only difference is that since more than one phenomena is represented, different shades, colors, or dots are used to distinguish between the bars. For example, in this figure, the bars are shaded with blue color to represent the values of birth rates, and the bars are shaded with maroon color to represent the values of death rates over different years in India. So, dear students, whenever a comparison between two or more related variables is to be made, we should always prefer multiple bar diagrams. Now coming to another important type of bar diagrams, which is subdivided bar diagrams, also known as differential bar diagrams. Dear students, subdivided bar diagrams or differential bar diagrams are those diagrams which simultaneously present total values as well as part values of a set of data. That is, in a subdivided bar diagram, each bar representing the total magnitude or total value of a given phenomena is further subdivided in its various components. Each component occupies a part of the bar proportional to its share in the total value. Different parts of the bars are shaded with different colors. For example, table 3 given here shows production of electricity from different sources in India, that is from hydro source and from thermal source during 2011-12 to 2014-15. So this table gives us the data relating to the production of hydroelectricity, thermal electricity, as well as the total production of electricity in India during 2011-12 to 2014-15. We can represent this data with the help of a subdivided bar diagram. As shown in figure given here in this slide, in the figure the length of the bars are in proportion to the total electricity production. Each bar is then divided into two parts. The part shaded with blue color shows the data relating to hydroelectricity production, and the part shaded with maroon color shows the production of thermal electricity in India during 2011 to 2015. Dear students, this diagram not only gives us the information about total electricity production in India, but also the production of electricity from hydro sources and thermal sources over different years. To distinguish between the two sources of electricity production, we used two different colors, that is blue and maroon color. Students, the fourth important type of bar diagrams is percentage bar diagrams. Percentage bar diagrams are in fact a different form of subdivided bar diagrams where we can show simultaneously different parts of the values of a set of data in terms of percentage. Dear students, in case of subdivided bar diagrams, we show the different parts of a set of data in terms of absolute values, whereas in case of percentage bar diagrams, we show them in terms of percentages. The percentage bar diagrams are generally used when the values are of high magnitude. In such cases, the use of subdivided bar diagrams may not be appropriate because when the values are of high magnitude, in such cases the use of subdivided bar diagrams cannot be used because some part of the bar may look very small compared to the other parts. So, in such cases, we should use percentage bar diagrams where the data are first reduced to percentages and then presented in terms of percentage bar diagrams. While constructing a percentage bar diagram, total value indicated by total length of a bar is assumed to be 100. Each part thereof is shown as a part of 100. Different parts of the bars are shaded with different colors to highlight the difference. Table 4 given here in this slide gives the data about the percentage share of primary sector, secondary sector and tertiary sector to gross domestic product in India during 2010-11 and 2011-12. And the same data can be represented by using the percentage bar diagrams as shown in this slide. In this figure, first of all, two bars of equal size have been drawn. They represented the total gross domestic product of India during 2010-11 and 2011-12. Then percentage share of primary sector to total GDP for the year 2010-11 and 2011-12 are shown at the bottom of the bars shaded with blue color, which is 16.66% and 16.17% respectively. From this level upwards, percentage share of secondary sector to total GDP of India for the same years are shown with a part of bars shaded with maroon color, which is 26.03% in 2010-11 and 25.45% in 2011-12. And lastly, the percentage share of tertiary sector to total GDP for the year 2010-11 and 2011-12 are shown at the top of the bars shaded with green color, which is 57.31% and 58.38% respectively. So, from this diagram, we can easily say that tertiary sector contributes most to the overall GDP in India during 2010-11 and 2011-12, followed by the secondary sector. Now coming to the last type of bar diagram, which is deviation bar diagrams. Dear students, sometimes only the difference or deviation of figures is to be shown with the help of bar graphs, and we can show the deviations or differences in figures by making use of deviation bar diagrams. Such graphs are also known as bilateral charts or gain or loss charts. Thus, deviation bar diagrams are used to compare the net deviation of related variables with respect to time and location. It means that the deviation bar diagrams are used to represent net changes in data. Such bars can have both positive and negative values. Positive values are shown above the baseline and negative values are shown below the baseline. Table 5 given in the current slide gives the number of houses in 8 small towns of India during 1991 and 2001 census. In some cases, there is an increase, while in other cases, there is a decrease in the number of houses. Like we see here that in town A, there were 200 houses during 1991 census, and during 2001 census, the number of houses increased to 250. The difference here is thus 50. That is an increase of 50 houses. If we see the town C or town D, for example, let us take town D, there is a decrease of 30 houses from 1991 census to 2001 census and the like. Now we can represent the differences in the number of houses in those 8 small towns of India during 1991 and 2001 census by making use of deviation bar diagrams like given here in this slide. Dear students, along the x-axis we took the name of towns like town A, town B, town C, etc. And along the y-axis we took the differences in the number of houses in those 8 towns from 1991 to 2001. As we can see here that the negative values or negative differences are shown below the baseline and positive values are shown above the baseline. And this type of diagram is known as deviation or bilateral bar diagram. Thank you.